Hey everyone, welcome back to my channel where I talk about all things tech and finance, and in this video I'm going to be going over optical character recognition. Now I do recognize that OCR is an incredibly vast industry. There are so many minute details associated with OCR. However, I'll be hitting the broad strokes to get you started, what you really need to know, and a high-level overview as to what OCR can do for you. Images, as you are well aware, are unstructured data. There are so many different components related to a specific image. It can be almost anything, really. So in this case, OCR is trying to extract text from a given image. That's really all it's doing. It's pretty difficult to actually implement. There's so many different variables and use cases to consider. However, I'll be trying to extract some text from an image in Python. I will be using Tesseract as my optical character recognition engine, one of the oldest OCR engines, known for its breakout discovery in the early mid-90s, and it became open source in late 2005. The model is now being updated, housed, and maintained by Google. The base of the model handles white on black text pretty well, and it paved the way for future prospects of optical character recognition. If you want to know more about the theoretical aspects of how Tesseract recognizes characters, I left a link in the description to the research paper that you see on screen. Okay, so I already created a real nice Jupyter Notebook-esque type of a format to go through optical character recognition. Now, the hardest part is actually just downloading stuff, right? So the very first thing that you want to have, or before you even begin, is to download the Tesseract. It's just a Python wrapper on the Tesseract model that you saw earlier on that paper. So really easy. All you do is do a real quick pip install. Now the more complicated part is to make sure that you want to download the OCR value over here, or in this case it's an executable file. I went ahead and downloaded the 64-bit one, and also know that this is September 6th 2021, and this might be subject to change. But that is the one I downloaded, and yeah, you just want to make sure you download it, and this is what you want to store it in. I just left it the destination folder as the defaults. Make sure that you keep that address in mind, because you're going to be pointing to an executable file within that downloadable file path, and then you're pretty much all squared away from there. So let's begin with the importation of Tesseract. This is where I'm setting the program files, Tesseract OCR, and there's an executable when to download that zip file, and you unzip the file, and that is what you want to point the command to. And also, there's also a lot of OpenCV-Python functions that I'm utilizing here, so do make sure to install this. There might be some hiccups along the way. You just want to make sure you're versioning all correctly. I'm using Python 3.8, by the way. So I went ahead and did that, and these are additional packages that I'm just loading on in. This comes from that, and this is just images, and then some plotting purposes and NumPy and operating system. So very first one I want to do is to just do one quick image. Let's do the tax one first, image name, and let me pull up what that tax looks like. Tax example. So this is what it looks like. This is the file that I want to read in, and I just want to get the characters that from this JPEG, or it might be a PNG. JPEG. Yeah, it is JPEG. Yeah. So I just want to get the various letters, and notice that it's not searchable. I'm clicking right here. I cannot search, do Control F and get some value. So hopefully I can get your first name, middle initial, last name, social security number, spouse's social security, these fields that exist over here. So let's see how that is done. And I'm going to be going through many of these examples that I have going on over here. So first one, tax example. So first thing I do, just read in the image, CV2, image read, and then image name. It's just the path of that name, real quick and simple. And if you want to resize, I'll be doing this a little bit down and further in the video, but if you want to resize from your, I think it was your width and height, these are just the pixel formats that you would want to format it in. So anyways, running this, I'm just going to be getting that image and getting some text. This is all you really need to do. It's like image to string. It uses the Tesseract model, and it gets that image. It tries to find anything that is readable. in terms of an English format, or you would have to tweak the actual language for it to be related to whatever you would want to extract from. So if you speak Turkish, for instance, then you would have to change the language behind the scenes, which is not that difficult, but you can sort of look it up. You just change the name, the nomenclature. But anyways, the default's English. Yeah, I'm just printing the text. This is the text that it's retrieving, and this is just the image that it's looking at. So this is the image that popped up on my screen right here. It's a little bit bloated out, but that's just the nature of that for that image. And let me just press like S right here. And so this is what it extracted. So if we load up the tax sheets right here, it's a little bit small. So anyways, let's just say 1040 let's see, form 1040, see if it extracted that. It did not. So notice that it's not 100% accurate, right? But it did get a few things. So let's see, Department of Treasury Internal Revenue Service. So if you maximize that, Department of Treasury Internal Revenue Service. So it definitely got that. What else did it get? So you can just scroll down. I'll make sure I upload this notebook down on GitHub, and you can sort of play around behind the scenes on how that is functional. So it pretty much got most of the fields that I wanted. It got wages, salaries, etc., attached form, so on and so forth. But the main part here is that it's searchable. You can go ahead and run a few regex functions. If you don't know what regex is, make sure you check out my other video that I did on regex. Really cool stuff. But yeah, you can massage the data so that you can get specific fields in a more or less like reproducible format if everything is in a JPEG or a PNG type of a format. So anyways, let's go on to the next example. Let's look at the Indonesian example, passport, and notice that I heavily vetted these images that I'm using, and these are not PII information or identifiable information. Made sure of that. So this is the image that I'll be using, just an example, and this actually means full name. I had to look that up to make sure it was correct, and there's obviously it can't identify anywhere, and it's just a random date of birth and date of issue. And yeah, I'm not sure what language that is. Maybe in the comments you guys can let me know what this is, but I assume it's Indonesian, maybe. But anyways, reading in a passport image. Let's see how that operates. So let's read in image name, and then just pass in the image and see what type of information we get. And this is the image that the model, the Tesseract model, is actually looking at. And let me just exit out of that. And this is the values that it extracted. So notice that it didn't get everything. Republic Indonesian, I don't think it got that. And also notice that it did get passports. So notice that the structure of the text can be a little bit daunting, but then you would have to go in again and just run a few regex functions to hopefully extract your necessary values out. There are a few ways to try and make this particular extraction more feasible to whatever you might do. But notice that it got some of the main criteria. So let's see if it got nama lengkap. Sorry if I pronounce that incorrectly, but it looks like it got that. It got full name, Kalamin. Yeah, right here, Kalamin. If I expand that, Kalamin, and sex, KS, so on and so forth. But anyways, let's go to a more difficult image. So it mainly got most of the text from that image, but let's see if we can get a more colorful image, like stop sign, for instance. And stop sign. Let's run that. So this is the image that it is looking at, and notice that it didn't print out anything, meaning that the model couldn't identify stop and all way. Sometimes it happens like that, but this is where the art form sort of comes in, and I tried my best to try and extract some of these characters out here, and what I came up with was right here. First part, let's try to grayscale this thing, standardize it, try and make it like a black and white type of a characteristic. But notice that it didn't extract anything, unfortunately. And also note that when you are using Tesseract, it is really good on black text on a white background. And notice that this is the opposite. So there are ways to try and approach this over here. And big shout out to Stack Overflow. You know, you already know the name of the game, but there is this person. I want to do a huge shout out to him. He was really wonderful. State Machine, really great. I used a good chunk of his code, so credit to him. You know, gotta give props where props are due. But first part, he was using something called gain division, and as I was just looking through this, it looked like it was like basically normalization. So basically normalizing your pixelated values to a specific point and making sure everything is in a very squeezed format. That's the way I perceived it. I might be totally wrong, but this is one method that you can try and do. I just ran what he had, and I just changed the various, you know, parameters in order to feed in my images here. But real quick overview, using get structure element, it's part of the OpenCV package, and the morphology, and it's basically like trying to get the shapes, I believe. There's a documentation on OpenCV. I'll make sure I put that in the description as well. And then here you're performing the gain division. Basically just copying and paste this from Stack Overflow to State Machine. You are a lifesaver. Anyways, this is the results of gain division. More or less, the normalization aspect is trying to white out the background, or just get the background and sort of just blot it out. Now, notice that there's no text that printed out, so which is okay. There are other methods to try and approach this, so let's exit that. And the other part is Otsu's thresholding. Some Japanese, really smart Japanese person, and forgive me again if I pronounce his last name incorrectly, but the main idea here is that it's trying to pinpoint the most important features. But the most important features will be the features that stand out, and it's trying to minimize the variance amongst the different pixels between each other. So if one pixel is very similar to another pixel, it'll make sure it sort of just like blacks that out. And you'll see this real quick. So the way to do this, it assumes that the image that's coming in is going to be a grayscale. It'll be, you want to convert your colorful image, assuming that it has a 3 dimensions, red, green, and blue, so RGB. Convert that to a gray. I'm still using the stop sign, and get the grayscale image, and you just pass this through to trying to find that variance threshold to maximize the feature representation of that given image. So let's run this again, and this is what that looks like. So really cool stuff. Is basically trying to, you know, just basically cast everything into, you know, either a black or a white binary output, and it's trying to, you know, just capture the base image, so to say. Really funky stuff if you want to look at that behind the scenes. I'll also attach the link as to more information on what Otsu's thresholding is. But also note that nothing printed out. The model couldn't identify this last portion. So there will be 2 more additional things before I essentially just give up. More information or more, I guess, technical knowledge will be needed in order to actually get all the characters. But there's another part, and it's called color filling or background color filling. And it's essentially just trying to enclose characters. And this is where another really neat function, I think I used that prior up here, is the morphology. Yeah, it's just trying to extract a shape and close the shape so that it can be more readable for the machine. So let's go ahead and run that. I think I already ran this, yeah. And let's run this. And nothing happened, but notice that it's more close, and that was the main purpose here. And then the flood filling aspect, which is going to be my last attempt, and also this note that this game also came from State Machine. Last attempt, this is where it's trying to fill in just color in the enclosed shapes that was identified in that photo. Last attempt, and voila, it identified all way with an, and I think it tried to identify that as an E, but it did not identify stop. And that's pretty much the extent of my stop sign with the all way part. I'm sure, I guess, if I go further into this, if there's more transformations that can be done, I can potentially identify what that character is. But this just opens the door to what you can actually do with optical character recognition. I've also attempted to, let's see, what's my other image? The yield sign, and I'll comment that out. So let's run this. same process. This is what the yield sign looks like. As you can see, it's the yield. But you know, as I was attempting to go to the grayscale, oops, let me exit that one out. Grayscale, you know, do the normalization of division, run this one, yield, you know, run the Otsu's thresholding, and try to get anything out of here, no, and then try to get those characters that are enclosed. As you can see, it already blotted out the characters. We're not going to get any additional information there. He was doing another text over here, but I was running through that with the shapes to try and, you know, just make sure the contours are real nice and smooth. However, it didn't work for that one, unfortunately. So there are definitely limitations, but the main idea here is that the 80-20 idea of where there's so much time and effort is spent on just cleaning data, and there's a lot of, I guess, algorithmic procedures you would have to do that. So the last portion is essentially the main idea here of where I want to try to get a PDF file, some PDF file. In this case, I just got one snippet of Berkshire Hathaway's 10K statement, trying to get these tables and make it more readable. As I was doing my finance thing, I was like, I'm reading all this stuff, but I really want to try to just, you know, trying to extract the information from these tables and, you know, run my various analyses on them. I don't really want to spend so much money on a Bloomberg terminal because that's like $24,000. That's a lot. Or unless they sponsor me, like, you know. But anyways, yeah, so let's go ahead and go with the PDF images. This is the image that I'll be working with, and it's just a snippet from the 10K, I think it was the annual report. But anyways, it's a snippet from one of those financial statements that I got. I saved it, I put it on my local machine, and this is the PDF. So I want to convert the PDF to a JPEG because PDF is not readable in the Tesseract library, but nonetheless, write that out to a PNG file over here, read in that image, and let's see what type of text it can extract. So this is what it looks like. This is the JPEG, or the PNG file, excuse me, of where it is trying to extract necessary information from this particular table. And notice that you can just like get the entire annual report or the entire 10K, look at these tables, extract it using some regex function, and then just put that onto like a spreadsheet, for instance. There's only a few variables that you would want to extract that should be sort of like next to each other in a way. And you can easily extract this table, and hopefully your tables are correct and up to date, and everything is correct. But you know, I guess that's where the service of Bloomberg and Reuters come into play, where they sort of already do that for you. But nonetheless, this is what the table is trying to, well, this is what the machine is trying to extract. So it looks like it got management's discuss show. So it didn't see that end part right here, and hopefully you guys can see that. But let me, minimize that again. And then it looks like it's not getting all of the information here. And there's one last ditch attempt in order to get the typical black text on a white background to try and, you know, make it a little bit more extractable, right? But notice that I got the revenues, got manufacturing, service on, and retailing, and missed the D. Cisco Suenez. I have no idea where that is. And service and retailing. So yeah, so as you can see, you got numbers, but ideally it would be in a nicer format. And there was one way that I was able to do that, and that was just to, you know, expand just resize the images over here. And so as you can see here, as I pull it up, this is the, right here. This is the JPEG that I was using, or the JPEG that I was or PNG, sorry, that I was using. And notice that the pixels that I am going to be pulling over here of that base image is only 594 by 77.4 pixels right here. So when I resized it, I went and let me pull up the new image _1. Looks the exact same. However, when I pull up the new image _1, pull this over here, details, I expanded it for the dimensions. I just did it by a factor of 3. You can do it by a factor of 10, 9, 8, 7, 6, 5, 4, whatever. I just want to expand the image so that it can be a little bit more readable for the machine to read. And let's run this, and notice that it just expanded. Notice also that the pixels within this particular image are a little bit fuzzy. The resolution here could definitely be maybe adjusted by using a smoother. However, this is the main point. Let's exit out of this, and this is what was extracted. Notice that it's just so much cleaner, right? It mainly got that very first line in one line, and it didn't get it over here. So just expanding the image, larger photos, very high res will definitely make your life a lot easier. And it got the tables, and it got the fine print as well, and got additional tables. Just run regex functions and you should be all squared away. There's so many really interesting applications on what you can do. You can apply this to accounting documents. You can apply this to 10Ks, annual statements, 10Qs, as I try to do over here. And there's just one page. You can do it with like thousands of pages and just extract data really quick and succinctly. So if you like what you saw, make sure you leave a like, hit that subscribe button with those notifications on. If you want to see additional content, let me know down in the comments down below as to what type of content you want to see. And I hope to see you in my next video. Thank you so much for watching.